Students, how are you all? Hope you are very fine, and I hope you have already watched the previous video of this chapter, atomic structure. So students, myself Mahima Laharia from Vijayanagar College Hospital. Today we are going to study the quantum numbers. As we all know, this is very important questions for your exam, and so now let us start our today's topics, quantum numbers. As already we studied in your 11th standard what are quantum numbers. So quantum numbers are used to describe the position and the energy of an electron in an atom. So the four quantum numbers which are required are principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. As we already know that principal quantum number is denoted by small n, azimuthal quantum number by small l, magnetic quantum number by m, spin quantum number by small s. Students, so before explaining the quantum numbers, let us revise some basics. For examples, as we say that inside the atom there is the nucleus in the center and it is surrounded by the different shells, and these shells can be termed as K, L, M, N. So the shells can also be termed as our energy levels, energy orbit, and they are numbered as 1, 2, 3, 4, 5. We denote them by alphabet K, L, M, N, O, P, etc. Then inside the shells there will be many subshells like S, P, D, F, and these subshells have many orbitals. So these सबसे पहले क्या पढ़ना है हमको, shells, then subshells, and inside the subshells there will be the orbitals like our 1s, 2s, 2px, and subshells are spdf, and inside these orbitals there lies the electron. So first shells, then subshells, inside the subshells there will be the orbitals, and inside these orbitals there will be the electrons. Now let us start our topic, quantum numbers. So to describe the quantum numbers, we can say that these quantum numbers may be defined as a set of four numbers with the help of which we can get the complete information about all the electrons in an atom. So what basically the quantum numbers gives, that tells us complete information of an electron in an atom, that is their location, where is your electron, what is about their energy, which type of orbitals they occupied, what are the shapes and the orientation of that particular orbital, etc. So thus the quantum numbers are just like the postal address of a man. As we know now, if we are asking some person's address, so what they will tell you, first the name, then they will tell you the city, area, colony, then their pin code, etc. So just like the postal address of a person, quantum numbers gives the postal address of an electron. So the first quantum number is the principal quantum number or the radial quantum number. It is given by the Bohr. It is denoted by n. It represents the name, size and the energy of the orbit or the shell to which the electron belongs. As already discussed, K, L, M, N, all are these energy orbits or the energy cells. So the principal quantum number n gives the information about the energy, the size, the name or the shell of the electron. Higher the value of the n, greater is the distance of the shell from the nucleus. As we can say that as the n value will be more, means for example, if we say that n is our 3, so the distance of the electron from the nucleus will increase. So we can just write that R1 is smaller than R2, smaller, this is our smaller than R3, R4, means as the distance increases, this our radii also increases. So higher is the value of n, greater is the energy. The next point is that nucleus will be in the center, and as the energy, as talking about the energy, if it is far away from the nucleus, if the electron is far away from the nucleus, the energy of the electron will be very high. Why? Because the nucleus has which type of the charge? Nucleus has the positive charge and electron is having the negative charge. So if it will be closer, it cannot move very freely. But if the electron is very far away, it can move freely. So if as the distance of the electron from the center increases, its energy also increases. So in comparing to E1, E4 will be higher, means the electron present in the fourth shell will have higher energy. The maximum number of electron in a shell is given by 2n square. So first shell, that is our K, Okay, how many electrons can come there? Just we have to apply the formula, that is our 2n square. So first shell, how many electrons can come? 2 electrons. Second shell, 2 into n square means it will be 8 electrons. Third shell, it will be our 18 electrons, and similarly fourth shell will have the 32 electrons. So now we can say that n can have any whole number values from 1, 2, 3, 4 to infinity, because if an electron is there in a system, it will have a certain value. कहीं तो वो रहेगा ना. It will be in any shell. Either it will be in the first shell, second shell, third shell. It will never be zero. The value of, if the electron is there, it will be in any shell. It's never zero. Then the angular momentum can also be calculated by using the principal quantum number with the help of the formula, that is mvr equals to nh upon 2 pi. So we can also calculate the angular momentum with the help of our principal quantum number. Number also determines the energy of the electron in hydrogen atom and hydrogen-like particles, means they have only one electron. So we can determine the energy of hydrogen-like atom by applying this formula, that is En is equals to minus 2 pi square me raised to the power 4 n square h square, where m is the mass of the electron, E is the charge of the electron, H is a Planck's constant, and N is this is the number of the shell, first shell, second shell, or the third shell. So in case of a multi-electron atom, it determines only the approximate energy of an electron. But if it is having one electron, so we can determine the energy of that particular electron by using this formula. Say that principal quantum numbers exactly tells us about the shape, energy of the orbit, name of the shell, and it tells us the distance of the electron from the center of the nucleus. It also tells us about the angular momentum, and it also helps to calculate our energy of the hydrogen atoms with the help of the formula En is equals to minus 2 pi square m e raised to power 4 n square h square. Now the second quantum number, that is the azimuthal quantum number. It is also termed as angular momentum quantum number, subsidiary quantum number, or secondary quantum number. This quantum number is given by the Sommerfeld. So this explained the atomic spectra and these subshells SPDF, these terms which denotes the subshells SPDF are taken from the atomic spectra. So what are the meanings? S for sharp, P for principal, diffuse, and the fundamental. So always we see in the periodic table is also divided into 4 blocks, that is S, P, D, F. So from where these S, P, D, F terms came, they are from the atomic spectra. These are the fine lines obtained, the sharp line, principal line. So the terms used as S, P, D, F here. So the azimuthal quantum number is represented by small n. This quantum number tells us about the shape of the atomic orbitals. What is the main thing you have to remember? Azimuthal quantum number tells us about the shape of the atomic orbital. It can be spherical, it can be dumbbell shape or double dumbbell shape. Quantum number depends upon the value of the principal quantum number. If the principal quantum number is n, so the value is L is equals to n minus 1. How we calculate the value? By using the formula n minus 1. So the L can have any integral values from 0, 1, 2, 3, 4, 5, etc. It can be 0, but the principal quantum number n can never be 0. So L represents the subshell which is present in a shell. So as we already discussed that shell, सबसे बड़ा क्या होगा? Shell, and inside that there will be many subshells. So we will discuss if suppose our n is equals to 1. So what will be L? L is equals to n minus 1. So what value you will get? 1 minus 1 is equals to 0. So student, to understand it clearly, you can like in this way. If the value of L is 0, 1, 2, 3, so the subshell will be, if L is equals to 0, it represents our S subshell. If L is equals to 1, it represents our P subshell. If L is equals to 2, it represents our D subshell. If L is equals to 3, it represents our F subshell. So once again you can see, if you have the value of L is equals to 1, so you have to calculate 0 as well as 1. How? If you are reaching to the first floor, you have to stand on the ground floor. So this is the ground floor and this is the first floor. Similarly, this will be the second. So if you have the value 3, so we have to calculate 1, 2, 3. Not like that. So let us see how it will be explained. So if the n is equals to 1, L will be 0. It means that n is equals to 1 means we are talking about the K shell, and it will be 0. It means it has only one subshell, that is the S subshell. So when we are talking about the first shell, it has only one subshell, that is S. Then next we can write it as 1s, where this 1 is the principal quantum number and this is the azimuthal quantum number L. Now if n is equals to 2, L is equals to n minus 1. So it will be 2 minus 1 is equals to 1. So I told you to 1 we have to calculate 0 also. 0, then we will come to 1. So we will have S as well as the P. So means when n is equals to 2, it will have two values, that is 0 and 1. So it is 0 for S and 1 for P subshell. So we will write it as 2S and 2P. Clear हुआ? Means is simple है. How much is the value of n? That much will be the subshells in a particular shell. Means if n is equals to 2, it will have two subshells, that is the 2S and 2P. Now, if n is equals to 3, that is we are talking about m, K, L, M. So, n is equals to 3, then what will be? N minus 1 is the formula. So, 3 minus 1 will be the 2. So, I already told you, हमें कहाँ तक जाना है? 2 तक. So, we will have 0, 1, 2. Clear हो रहा है आपको ये? If it is 1, so we will count 0 and 1. If we have the value 2, 3 minus 1 is equals to 2. So we will have to move up to 0, 1, 2. Okay. So now we can say that our third shell will have three subshells, that is the 3S, 3P and 3D. Similarly, if n is equals to 4, L is equals to n minus 1. So F4 minus 1 is equals to 3. So similarly, we will have 0, 1, 2, 3. We have to go from 0. It means S subshell, P subshell, D subshell and F subshells. It means that when n is equals to 4, it will have our 4 subshells, that is the 4S, 4P, 4D and 4F. Guys, our values. So if n is equals to k, it means we are talking about the first subshell. So when n is equals to 1, only one subshell is there, that is S subshell, that we can write as 1S. And when the n is equals to 2, there will be the two subshells, that is the 2S, 2P. N is equals to 3, there will be the 3 subshells, that is the 3S, 3P and 3D. When it is 4, so it will be 4S, 4P, 4D and 4F. When n is equals to 4, they will have 4 subshells. When n is equals to 5, they can have 5 subshells like 5S, 5P, 5D, 5F and 5G. Why I am writing this? Next, after F, we have to mention the G. So now we can say that the number of subshells in a shell is equals to the principal quantum number. So number of how many subshells will be there, it is equals to the principal quantum number. As it is 3, so there will be the 3 subshells. Next point, the relative energy of the various subshells in a shell is as follows. Means the S is having the least energy, then P, then D, then F. So as we know that S is having the least energy, F is having the highest. In this order you have to remember. S is having the least energy and F is having the highest energy. So the subshells having the equal L values but with the different n have the same shapes, but their size increases as the value of n increases. So to understand this, let us see the two orbitals, our 1s and 2s. Their L is same, means both are having L value 0. But as this is the 2 number, so what they are saying that they have the same shape, spherical shape. But what they are saying that their size will increase as the value of n increases. Similarly, 3s will have bigger size in comparing to our 1s or 2s. Similarly, 2p, 3p and 4p, we see that 4p will have the maximum size, means it will be the larger in the size. So maximum number of electrons present in any subshells can be calculated by using the formula 2 into 2l plus 1. So how we can calculate the number of electrons present in any subshell? We can calculate it by using the formula 2 into 2l plus 1. So let us see calculations here. If it is L as subshell, so S, our L is equals to 0. So how we can calculate? We will put 2 into 2l plus 1. 2 into 2l. L is our 0. So it will give our maximum electron can accommodate in the S subshells will be 2 only. For the P, L is equals to 1. So you will put it here 2 into L plus 1. So 2 plus 1 is equals to 3. So 3 2s are 6. Similarly, D is equals to L. When L is equals to 2, that is the D subshell. So 2 into 2, 4 plus 1, 5. 5 into 2, it will give you the 10. So D subshell can have the 10 electrons. Similarly, for F, L is equals to 3. So 2 into 3 plus 1 means 6 plus 1, 7 into 2. It will be the 14 electrons. So student, we can just say that our S subshell will have 2 electrons, P will have 6 electron, D will have 10 and F will have the 14 electron. We can calculate it with the help of the formula 2 into 2l plus 1. So just we can say that azimuthal quantum numbers tells about our shape of the atomic orbitals and also tells us about the subshells. Explain the magnetic quantum number in detail. So student, as I told you, magnetic quantum number tells us about the numbers of orbitals and also about their orientation in space. So if n is equals to 1, so L is equals to n minus 1. It means that if it is k shell, so it will have the value for L will be 0, means it represents our subshell S. S is for the 0. If L is having the 0 value, it represents the S subshells. So if for this, the magnetic quantum number is calculated by the formula m is equals to 2l plus 1. So this formula gives us the number of orbitals in a particular subshell. So when L is equals to 0, it represents S subshell. What will be the value of m? It gives us the 1 value. So it means that this subshell, S subshell, have only one orbital, and to determine the orientation of this orbital in space, that is xyz, we will put this value in the number line. So the first value in the number line, as we know it, is 0. So that if our L is equals to 0, m is also 0. It represents that if we are talking about S subshell, its shape is spherical. It does not have any orientation in space. So if our L is equals to 0, m is also 0. Now let us see if our n is equals to 2. L is equals to 2 minus 1 equals to what you will get? 1. So as I already discussed in our azimuthal quantum number that we have reached to 1. पहले में ground state पे चलना पड़ेगा 0 पर, फिर हम first floor पर आते हैं. Then we come to the second floor, means अगर हमको value 3 मिलती है, so we will calculate 0, 1, 2 and then 3. So similarly, if n is equals to 2, L will be 1. So for 1, we have to count 0 as well as 1. So we know that if the value of L is 0, it represents the S subshell, and if it is 1, it is second subshell. As n is 2 here, principal quantum number is 2 here, we are writing it as a 2s and 2p. So as we already calculated the value for L0, m is also 0, so the same it will be for the 2s also. So now we can calculate when L is equals to 1. We will calculate value for this one. So for the P subshell, when L is equals to 1, it represents the P subshell. So now we can say that m is equals to 2l plus 1. Put this value 2 into 1 plus 1. You will have 3 orbital, and this is the number of orbitals in the P subshell. आप already पढ़ चुके हैं. P have 3 orbitals, that is px, py, pz. तो ये जो orientation होता है हमारा px, py, vz. To find out this, we have to put this value 3 orbitals. We have to put this value in the number line. So the values lies from minus L to plus L. So what is L? L is equals to 1. So it will be minus 1, 0 and plus 1. It is written like that. For the pz, they are assigning the value 0. For px, it is plus 1. And for the py, it is our minus 1. So these values are very important. Sometimes the numericals are asked. So if for example, if n is equals to 2, l is equals to, they will give you what they will can give you px or py. So you have to write the value of m. So m will be plus 1 for px, pz it is 0, py it is minus 1. Similarly, if n is equals to 3, so l will be what is the formula of l? N minus 1. It will be 2. So we can write it as 0 1 2. हमें ground state से जाना पड़ेगा. So 0 1 2. It means that n is equals to 3. So we are talking about our third shell, that is 3s, 3p and 3d. It can have 3 subshells, 3s, 3p and 3d. So for s, we have already calculated. If our l is 0, m is also 0, s it is our s, it means it is our 0, and when the l is 1, it is the p subshell, and now n l is equals to 2, it is the d subshell. So we have to calculate the value for 2 here. So now we will put l is equals to 2 here. So let us see, m is equals to 2l plus 1. So l is here 2, it will be 5. It means that our d subshell have the 5 orbitals, and this will have the orientation from minus l to plus l. So we will put these 5 values as the form of l number, that is l is equals to 2. So we will start writing from minus 2 to plus 2. So we all know that d have the 5 orbitals. These are our dxy, dyz, dzx, dx square minus y square and dz square. So these 5 orbitals are assigned these values. This I have written from our modern, we can say Pradeep's book of 12th standard, 11th standard. And so you can also use these values. It's our dxy is given the value minus 2, dyz is given minus 1, dz square 0, dxz plus 1 and dx square minus y square as plus 2. So these are very, very important values. They are very helpful for the numericals also. Similarly, if n is equals to 4, l will be 3. Means we have to go from 0, 1, 2, then we will reach to 3. It means when n is equals to 4, there will be 4 subshell, that is S, P, D, F. So we can write as 4S, 4P, 4D and 4F. So we already calculated for 0, 1 and 2 L values. Now we will calculate L is equals to 3. So what it will be, we will put this value in the formula 2L plus 1. 2 into 3 plus 1 give you the 7. So there will be the 7 orbitals in the F subshell. Now we will put this value in the number line. So what value we will put on the number line? This our third value, 3, L equals to 3. So we will start from minus 3 to plus 3. So they will have minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So these are the 7 F orbitals. As they are very complicated, so we don't write their names. We can summarize that if L is equals to 0, M will also 0. If L is equals to 1, M will have 3 values, that is minus 1, 0, plus 1. And L equals to 2, M will have minus 2, 2, plus 2 values. If it is 3, it will have the minus 3, 2, plus 3. That is the values will go up, means they will have the 7 values. So already we have calculated these things in details. Hope if we have the maximum number of orbitals in a subshell, we can calculate with the formula, that is 2l plus 1. So as we know that our values of L are 0, 1, 2, 3, that is our SPDF orbitals. The maximum number of orbitals are 1 in S, 3 in our P, 5 in D, and our 7 orbitals will be in the F. We can calculate it with the help of our formula 2L plus, we have already discussed it. So the maximum number of orbitals in a shell is equals to n square. This you can learn, n square means it is the principal quantum number n. So you can say n is equals to 1, that is we are talking about the K, L, M, N sub shells here. So it will be 1 square, that is equals to 1, means it has only one orbital in a first shell, it's our 1s. So in the second shell, it's our 2 square. There are 4 orbitals, that is 2s, 2px, 2py, 2pz. If it is third shell, they have 9 orbitals as our 3s, 3px, 3py, 3pz. 3x square minus y square, 3d z square, 3d xy, 3d yz, and 3d zx orbitals. Similarly, when we are talking about the fourth shell, there will be 16 orbitals, that is the 4s1 orbital, p will be 3, d will be 5, and f will have the 7 orbitals. F subshell have the 7 orbitals. It also, we can say that the magnetic quantum number tells us about the orientation of the orbitals in the three-dimensional space xyz, and it tells us about the shapes of the orbitals. So now let us see our next quantum number, that is our spin quantum number. It is explained by the Goldsmith. So it is the simplest and the easiest quantum number. So it is denoted by S. As we all know that electron hai, it will spin. So this quantum number tells us about the spin direction of the spin of an electron around its own axis. It have only two possibilities: either it will spin clockwise or it will spin anti-clockwise. So if it is spinning clockwise, we are assigning it as value plus half, and it is moving anti-clockwise, we are giving as minus half. For clockwise spin, we are using upside arrow, and for the anti-clockwise spin, downside arrow is used. So the maximum 2 electrons with opposite spin can be placed in orbitals. So we are using this like of the shape for the orbitals. 2 electrons with the opposite spin is the correct option, and this is not the correct way to write the electrons. So electrons with the same spin are termed as spin parallel, and the electrons with the opposite spin are termed as spin paired. If you want to make a table, you can make from this textbook. So as we know that for the first shell K, there will be only one subshell, that is 1s, and the magnetic quantum number when L is equals to 0, M is also 0, and if it is having 2 electrons, its values for the spin quantum number will be plus half, minus half. Similarly, for the L is equals to 2, it will have 2s and the 2p, and for the 2s, they will be having 2 electrons, and there are 3p orbitals. So px, py, pz, the total spin will be 6. So in this manner, the first shell has 2 electrons and the second shell have the 6 electrons. Third shell, when m is equals to, when we are talking about the third m shell, that is n is equals to 3, it will have 3s, 3p, 3d, and it will have 2 electrons in the s orbital, 6 electrons in the p orbitals, and 10 electrons in the d subshells. So the total number of electrons will be our 18 here. So for our next n is equals to 4, it will have our in the s subshell 2 electrons, in the p subshell 6, and d subshells there will be 5 orbitals, so total 2 electrons. For the f subshell, it will have 14 electrons, so total there will be the 32 electrons. So this, if you want to make a table, you can make, and we can also conclude that how to calculate the number of orbitals in a subshell by 2l plus 1, number of electrons in a subshell 2 into 2l plus 1, number of orbitals in the nth shell is equals to 2n square, maximum number of electrons in the nth shell is equals to 2n square. If we are talking about s subshell, there is only one orbital. If p, there are 3 orbitals, d 5 orbitals, f there are 7 orbitals, and if we are talking about the g, there will be the 9 orbitals, and the values by the latest conventions are as follows. If you want to write, you can write it down. So the plus minus conventions are sometimes taken without any distinction, so you can just see it. Do write the notes, and I have already told you can write at least 5 points for each quantum numbers. Take the screenshot and complete your notes work. So this is all for the quantum numbers. Practice them, and in the next video I will try to give some numericals of the quantum numbers. Thanks for watching. If you like this video, please share with your friends. Do subscribe my channels. Thanks for watching.